Good morning, scientists, and welcome to science class. As Mr. Gladwell said yesterday, we are going to go ahead and hit the ground running here talking about dew points. And we are going to be doing an experiment today about calculating dew point and what makes a dew point change with different types of air masses. We're going to be talking about air masses last week in fronts, and humidity helps us dew point help us understand what are the characteristics, the things that are true about an air mass, and what makes them different. And so, dew point, what is dew point? So, before we do our experiment and ask you to think about this, I'm going to do a little research here. First off, what is dew point? Dew point is simply a temperature at which water vapor will condense into liquid. That's a temperature we need, and that temperature then is going to take all the water vapor that is in a gaseous form is then going to condense onto something. The same thing that you saw earlier in the week when you poured that glass of water and then you saw water condense on the outside of the glass. It's just that temperature, right? And what changes dew point? What makes dew point happen? There are three basic things. It's kind of two and a half. First thing is how much water is there. So if I had this glass of water, dew point is simply put how much water is in the atmosphere, and the more water that is in the atmosphere, the higher the dew point is going to be, and the less water there is, the lower the dew point. The dew point is going to be. Other things that affects it are air pressure. Air pressure does affect it, but it does not affect it very much. And how high in the atmosphere you are is also going to affect it, which is about air pressure, because the higher in the atmosphere you go, the air pressure is going to change as well. And so when you hear weather forecasts next week, when you do your weather forecast, when you document what what our weather scientists and meteorologists are saying, they're going to point towards dew point. And so this picture from Sarasota, Florida, from some time, the dew point was at 76%. That meant that at that temperature, 76 degrees Fahrenheit, once the temperature hit that level and below, water was going to start to condense into a liquid. And that's kind of what the dew point is. And we'll talk more about this tomorrow. So that just lets you know the dew point. The higher the dew point, the more water there is in the air. Lower the dew point, the smaller amount of water that's in the air. So that's just a little bit about dew point and how dew point's calculated. We're going to go ahead now and transition into our experiment. So our research question, what we're trying to learn is, how does the dew point change between two different air masses? Weather is all about air masses and how those air masses come together. Dew point is one way we can say that's different than this, right? As well. Many of you might know that Miss Vrana and I are actually brother and sister. And so one characteristic between us is, there's lots of things. We'll go with my hair is shorter than Miss Vrana's, and Miss Vrana's hair is longer. So that's one characteristic, just like dew points are characteristics that tell the difference between. Very few people confuse Miss Vrana and myself. So how does it change between two kind of air masses? So what we're going to do is we're going to do an experiment doing two different air masses. One is going to be inside my house, and other is going to be outside. Outside, and what the dew point is, we're going to calculate the dew point inside and outside. All right, inside and outside. All right, I need you to do right now is make a prediction. All right. And I want you to go ahead and copy down this format right now. Go ahead and just do that in your journal or a piece of paper you have. You do not need to copy down the research question unless you really want to, but you have access to it here. But I want you to copy this down. If you measure the dew point inside of a climate-controlled house and outside, so we're going to do two of these, then what do you think is going to happen? All right. And remember that our prediction needs to be based on what we're trying to learn about dew point. All right. So then are the dew points, really there's only three options. Dew point's going to be the same for both, or one's going to be higher and one's going to be lower. And which one do you think is going to be higher and which one's going to be lower? And don't get caught up. You don't need to do a research, right answers. It's just you to make a prediction before we get started. So if you want to go ahead and pause the video here, think about it for a minute, and then go ahead and write down your hypothesis. All right, so now we're moving on to our procedure. If you have these materials at home, watch the video. If you want to do this yourself, I would say go ahead and do it. The only issue is you're going to need a thermometer, and not just one to see if you're sick or not. You're going to need a thermometer where you can see the actual temperature at all times. So if you have one of those, something like this, a meat thermometer, it's going to matter how low the temperature can go as one. Something you can put into a liquid as well. We're going to need some room temperature water, which we'll have right here. We're going to need some ice cubes. We have right here. And then just kind of some uninsulated cup or container. These metal ones work really well, but any container will work. And then so what we're going to do here is I'm going to head outside and then back in the house, and we're going to conduct both these experiments and write down some data. So I will see you in a moment. All right, here we go, guys, and we're going to go ahead and do our experiment here. So according to the directions, we're going to go ahead and take some room temperature water. So water I just put in a cup and left out for a little bit to get down to room temperature. It's about 236 milliliters. That's 1 cup. And I'm just going to go ahead and pour that room temperature water in there. And I'm going to go ahead and take this thermometer and place it in there and give it a second to adjust. As I'm finding this temperature, I am keeping it in the water while I'm looking at it here. All right, now what we're going to do is we're going to slowly start putting ice cubes in and just watching for condensation to start to show up. Okay, guys, I'll look here. If I bring my finger down, it's hard to see. You can kind of see the condensation showing up, and I'm going to pull it up here. All right, we're looking at 3 degrees Celsius. All right, 3 degrees Celsius on the thermometer. All right, so 3 degrees Celsius is when we finally had condensation show up. All right, if I get this closer, that doesn't really help, but you can see if I pull my finger down, you can start to see, all right, those lines coming through here a little bit. There you go. To see that condensation has started to show up right on this glass. So so things to think about. You can notice outside it is night, so it is Tuesday night. Just to let you know when this happened. But remember, temperature doesn't really affect dew point. It's how much water is just in the atmosphere around us here. Okay, guys, we're here. We got a room temperature water right here. It's 23 degrees. 236 milliliters of water. All right, we have no condensation present. All right, and then we're just going to start dropping ice cubes in. Looking carefully if you see any condensation. Oh, there it is. Some condensation showing up. All right, we're at 14 degrees. If you have a hard time seeing it, if I pull my hand down, it doesn't help seeing it very much. All right, we can kind of see it right there. All right, you see that condensation is right there. All right, so now we're going to go to our data table. So go ahead and go back to your hypothesis, and we're going to go ahead and record this data. All right, we're back to our data table. So go ahead and we're going to write down this data table. Really, this left side data table is all we really need. Our first temperature is no condensation. Our second is condensation. So outside, we started at 23 degrees Celsius. That's Celsius, remember, not Fahrenheit. That's why it seems a little low. and just remember, reference point is 0 degrees is freezing. No condensation at 23 degrees, and we didn't see condensation show up till 3 degrees. And then on the inside, we started 23 degrees Celsius because we had room temperature water. And that was room temperature inside the house, by the way. And then we saw temperature at 14 degrees Celsius. Let's see for Celsius. And then put yes. This was our data from our experiment, as we saw that the dew point was significantly higher inside and was lower outside. And so some things to think about. What's happening inside is inside this house. It is insulated. We are also inside. This is the kitchen. We were boiling. I was boiling water earlier today. Oven was running. Dishwasher is right over here. Sink is right over here as well. So that just gets you a little sense of what's happening inside the house and outside. Obviously, we saw that cold front come through on Sunday, and temperatures have been cooler, much cooler here the last few days. So keep those in mind. Tomorrow we're going to look at this data and then talk a little bit more about dew point and what it means to predicting weather and what it has to do with weather. And we'll also connect that obviously back to what Mr. Gladwell talked to you guys about on Monday and Tuesday. So see you tomorrow as we dive more into this data and try to figure out what is actually happening in this experiment. See you tomorrow. Okay, one more thing. Just for the record, Miss Verana is my sister from another mister. So I was joking, just to make it clear. We are not genetically linked in any way. So just want to make that for the record, in case you don't realize that Mr. Cook rarely doesn't use sarcasm or joking around. So there we are. We'll see you tomorrow about dew point.